Okay, so we are going to talk about interpolation and extrapolation. We talked about it earlier. Alright, so now we're going to work more into this. EQEO love asking these questions. So Jenna, she borrowed money from her parents for a school field trip. She repaid the loan by making regular weekly payments. The graph shows how the money is paid over time. That the data is discrete because payments are made every week. What does that mean? Right. So like if I'm paying every Sunday, I'm not making a payment on the Wednesday or on the Thursday, and so the data is discrete. Okay. So how much money did Jenna originally borrow? Yep. $200. So originally means at the beginning. So at the beginning, where does your line start? It doesn't start in the negative. It starts when x is 0 to represent a 0 week. So it's $200. And since you said dollars, I better see that unit dollar sign. Okay. How much money does she still owe after 3 weeks? Joshua? Okay, so what you want to do is 3 weeks means I'm going to look at the 3 on my x-axis and I'm going to draw a dotted line up to my line. Alright, and then when I reach my line, I'm going to draw a line across and then read off the graph. And that is how much, Joshua? $140. What? Right. Okay, $140. Keep in mind of the scale. Make sure you read the scale properly because it's every 20. Every box is $20. So that's 140. How many weeks will it take Jenna to repay half of the money she borrowed? So how much did she borrow originally? 200, and then half of it is 100. So now I'm looking at 100 on my y-axis, and I'm going across. Okay. Once I reach my line, I'm gonna go down and see where it points to on my x, which is 5 weeks. Right. I've seen people make silly mistakes and tell me $5. Okay. How many weeks will it take? And then you say $5. Doesn't make sense. Okay, so make sure you have your units correct. How long until she repays the whole debt then? Yep.
Well, so the x-intercept is 10, so 10 weeks.
Right. So for it to reach $0, it's your x-intercept, which is 10 weeks. Okay, and then now, if you take a look at this problem, how much did she repay every week? Other than, yeah, okay, Charles. 20. How did you know?
Because it says
$20, Charles.
okay.
How do you know?
Because it's like you have eyes, so like
Mathematically? Okay, how did you use your eyes to,
which you can see, and then if you just like divide both by 2, you get like every week.
yeah. Okay, so 2 different ways you can tell. She borrowed $200. It took 10 weeks to repay everything. So it does mean she paid $20 a week. Another method you can see is after 1 week. So after 1 week, it's at 180, which means it's going down by $20 every week. So $20 per week. Don't forget your unit right here. Your unit, remember unit rate? We talked about it. Unit rate has 2 units, so $20 per week. Okay, nice and easy? Yeah. Okay, example 2, using extrapolation to solve problem. So Maya jogs on a running track. This graph shows how far she jogs in 10 minutes. Assume Maya continues to jog at the same average speed. Use the graph to predict how long it will take Maya to jog 2,000 meters. Okay, so what's wrong with the graph right now? Okay, I can't tell the answer right off the bat because, yep, doesn't go up to 2,000. So what should I do? Yeah, extend it. Simple as that. Okay, so extend this graph. So something like this. Okay, and then here instead of 1,200, what is the next number here? Yep. 1,400. How do you know? Yeah.
Because we're just continuing the scale that they
Yeah. So in order to use extrapolation, you have to continue the scale that was originally set. You can't create your own scale. So 1,000, 1,200, 1,400, 1,600, 1,800, and then 2,000 up here. Same thing for your x-axis. You have to continue the pattern. So 12, 14, 16, 18, 20. Okay, and so for 2,000, which is up here, I'm going to draw a dotted line across. On the test, when I say show your work, this is part of showing your work. So it's drawing this dotted line. Alright, once I get to here, I'm going to draw a straight line down to my x-axis. And so how many minutes? How many minutes is that? It's a little hard to do on your handout, but based on mine right here. Yep. 17 minutes.
Wait, but I calculated and it's 16.6 repeating.
Oh, well.
round it out.
Yeah, round it. It's roughly about 17 minutes. Right here is because it does say use the graph. So yes, it's not as accurate. Algebraic method is more accurate, and we will get into algebraic method later on when we do analyzing.
On the test, if you just put 17 because
It's fine.
close, it's fine.
Yeah, because it is based on your graph. On Thursday, you guys are going to do an assignment, and it's also going to be based on your graph.
Yeah.
So your answer could be different than Armin's answer, and it could be different than Charles' answer, and so forth. So that's how I tell if you guys are copying each other or using your own.
Exact same scale.
Come on, bro.
Exact same line and everything, right? Okay. Predict how far Maya will jog in 14 minutes. So 14 minutes, I'm going to go to 14 on my x-axis. Draw a dotted line up to the graph right here. Alright, and then across. Okay, so again, showing this dotted line is part of showing your work. Okay, which is roughly about
1680.
It's a hunch.
Okay, so did you do that by calculation or you estimated?
It's a very great guess.
It's a very good guess.
Okay, very great guess. Okay, so I know this is 1600, this is 1700, so in between you guys chose 1680. Okay, sure. Okay, will you get full marks for 1680?
No.
Meters. Right. Alright, don't forget the units. Alright, if you wrote 1650 on the test, you'll get the mark. Okay. What assumption did you make? Yep.
At the same speed, bless you.
Okay, she maintained.
Wait, isn't it also like right on the question?
The same speed
Yeah, this is the additional question.
throughout. Okay, but
They said assume.
is that reasonable?
No.
No.
Unless you run out of time.
All right. So after maybe 30 minutes or so, what do you think would happen, realistically?
Get tired. You slow
And
down.
then you slow down. Okay. So yeah. So then it becomes like a curve. Okay. But then and then eventually, what do you think will happen?
Plateaus.
flat out because she's taking a break. So it's just, okay, and then it's a horizontal line. Okay, so the fact that we're drawing a diagonal line continue going, it means that she's still running and she's maintaining the same speed. Okay, last example right here. I want you guys to figure this out. Take 30 seconds. It shouldn't take you more than 30 seconds to figure it out.
I don't know if
Ours is like really different.
Yeah. Well, not really different, but it's the same. I tried to draw the same graph. Okay. So take 30 seconds. 15 seconds. Okay. 5 seconds. Okay. And Cheyenne, what did you get for A?
A is -6 and B is this is 6 and
Okay, so you said is -6. So let's see. When y is 3, which is right here, you have to extend your line out. And then when you go across,
I may have did it wrong because like my graph is not big enough.
oh,
I may have screwed up.
no, it's right.
Okay.
Alright, and then coming down, you'll see that it goes to -6. So when y is 3, you get the point x is -6. If I were to write this as a coordinate, how do I write this as a coordinate? Sorry? -6, comma 3. Right, that's right. Alright, did I use interpolation or extrapolation? Extra. Alright, and then for B, when x is 5, so right here, alright, draw up to your line, and then across. So it is roughly about, yep, 6.6686, okay. So for, I got y equals 6.666666 repeatedly. Right? If I were to write this as a coordinate, what would it be? Yep.
5, 6.6.
Perfect. All right. So remember, for all of this, in a line, it's actually a line. How many points make up a line?
All of them.
Okay. Another answer? Infinite. Okay. A line actually has infinite number of points. So for any one of these points on this line, you can always write it as a coordinate. Did I use interpolation or extrapolation? Yep. Inter. Because it's within the graph. Which one is more accurate? Yep. Interpolation, because extrapolation, just like in Maya's jog, you don't know what happened after. Okay, but at least here, we know that in the first 10 minutes, she did run consistently at the same pace, on a treadmill, I guess. Okay, so that's today's lesson. You can see, nice and short, 14 minutes. I will upload this video on YouTube as well if you need a review for homework. Yes. Alright, since tomorrow is take your kids to work day, you do have extra time. My morning class worked really well and finished. Yeah, okay, so 4 to 14, not a lot. And if you want a challenge, do number 15 as well. Okay, so for the challenge, the number 15.
I'll just go back to staring at the election map. Thank you very much.
Okay?
I only have